Hi guys, welcome back to this channel. Today we're going to be talking about motion, which is the second topic according to the JAMB curriculum. All right. So here today we're going to be looking at motion and every damn thing that has to do with emotion. The first thing we want us to note is that when we're talking about motion, then that should that we're talking about the change of the position of the body. Let's assume this is a position A here. We have position A and we have position B. And then an object is here now. Maybe after a few seconds, the object has changed its position from there and is now in this way. Therefore, we say there is change in the position of the object, therefore motion has taken place. Okay, motion can now we can have this change of supposition in different manner. So the first one is translational motion, which is otherwise known as linear motion. So this is the motion a body taking on a straight line. So there's a motion of a body on a straight line. Maybe a guy walking from one place to the other. That's translational motion. All right, so now we have random motion. Random motion, this is kind of motion that all these butterflies within inside. Like, they don't have a particular direction to always travel from one, they travel in zigzag manner. So we call it random motion, like dragonfly, butterfly, housefly. So also we have oscillatory motion. Oscillatory motion is a type of motion, we call it to and fro motion. So that's when a body is swinging, let's say we have a body attached to this side, then it's swinging to, fro, this side. So we say that's what oscillatory motion. It's otherwise known as vibrating. So that's about vibration. So that's we have vibratory motion, which is otherwise known as vibratory motion. We have rotational from the word rotation, when object is rotating around a particular point. We have circular when it's in circular motion. Then we have let's take note of something here. Rotational motion is quite different from another side. Rotational motion always take place when we have two objects moving probably in the same direction or in opposite direction. Let me give you a scenario. Let's assume you're traveling by car, and then you'll find out that after traveling for a second, um, on express, let's assume another car is passing by. Probably the car is faster than yours. You get to know that since you are in the car and you're not moving, it just seems like your car is not moving, while the other car is just moving forward. That's how you're going to feel it. And the other way around, let's assume that you are the one that is running faster than the car. If you're overtaking it seems like you are not moving, but the other car is moving backward. That is, it's just going backward instead of it to move forward. So that's how it's going to look like. And whenever you are moving in opposite direction, maybe you are going to Lagos and the car is coming from Lagos. That feel that once you guys come to get to the same state, it seems like you are faster than the way it seems, because immediately the car passed through your car, it seems like the car is running at a very high speed because you are not moving. So in short, let me quickly give you this. Whenever the two bodies that are in relative motion are moving in the same direction, when they are moving in the same direction, you have to subtract, okay, their velocities. And when they are moving in opposite direction, you have to add up the velocities. For example, if you have a car moving with 50 kilometers per second, and you have another one also moving in the same direction that is moving with 30 meters per second. If they ask you to calculate the relative velocity, what you just have to do is, since they are moving in the same direction, follow this, right? So that shows that you're going to have 50 minus 30, which should give you 20 meters per second. So that shows that the relative velocity is 20 meters per second. It will seem like the car is moving with 20 centimeters per second. But when they are moving in opposite directions, saying like 50, this one is moving in this direction, and you have another one that is 30 meters per second in this direction. Therefore, the relative motion, the relative velocity now will be 80, because you're going to add it together, 80 meters per second. All right. So this is about the types of motion. So let's take a look at let's move forward. Now let's go to equations of motion. Now we're talking about equations of motions. We have a lot to do here. The first thing is note something that u simply means initial speed or initial velocity. And what does it mean? In most cases, not here, when a car is at rest, that simply means that its initial velocity or the speed presently is equals to 0. For example, if a question comes in a manner that a car starts from rest, since the car starts from rest, therefore the initial speed or initial velocity of that car is 0, not that. All right. Or there's a question that says the car was brought back to rest, or before it was brought to rest. Brought to rest. Anything that has to do with rest simply means 0 meter per second. That's the velocity there is 0. Okay. Please take note. And then we have V to be the final velocity. Okay. So from here, we'll talk about we know V velocity is the distance over time or displacement over time. We are going to look at acceleration. Acceleration has to do with increase in velocity per time. That's V minus U over T, where V is our final velocity and U is our initial velocity over time. Not something, no matter what, the acceleration must always be positive. For acceleration to take place, final velocity must be greater than the initial velocity. Okay. While we have of deceleration, which is also known as retardation. When we're talking about retardation, it's still the same formula, V minus U over T. But here, our U is greater than our V. Therefore, your answer must be negative, no matter what. Whenever you are dealing with retardation, your answer must be negative. That is very, very compulsory. Okay. All right. From here, we're going to list out the equations of motion. I'm going to provide those there. So let's take note of these equations. They're very important because you're going to be making out of them and why. The first one is, let's say S is equals to V plus U over 2, then T. Then we have V equals to U plus AT. The third one is S is equals to UT plus half AT squared. And the fourth one now is V squared is equals to U squared plus 2AS. Now let's know something. Why do you have these equations? The first thing you have to do whenever you're given a particular question, the first thing you have to do is to list out the parameters. What are those things given in that question? What are those things given in that question? That will not determine the kind of formula you are going to use. For example, you said a body is moving with an initial velocity of 20 meters per second. Okay, I'm going to write initial. What I told you, initial is what? U. That's 20 meters per second. That's the initial speed. Then it said it's subjected to a uniform deceleration. Deceleration, we're going to use A for deceleration, but don't forget it's deceleration this time around, is equals to, deceleration always comes in negative, that's 2 meters per second. Great. And we said we have to calculate the time required to bring the body to complete halt, that is to bring it back to rest. All right. So bringing it back to rest, that shows that presently the body is at rest. Therefore, the final velocity of that body is 0. That's the body is at rest 0. So we are looking for the time required, that's t. So from here, I told you A equals to V minus U over T, and that will give us 0, which is our V, minus, oh, sorry. So using this equation, we have, if I cross multiply, because we are looking for time, we have AT equals to V minus U. Therefore, from here, I will divide both sides by A. So we have T equals to V minus U over A. So what's our V? 0 minus what's our U? 20 meter per second. Then our A is minus 2. So therefore, I will say my T now equals to minus 20 over minus 2. Minus cancel minus, and this one shows that we are going to have 10 seconds. Did you see that? It's quite simple. So what are the parameters given to you? U, A, V, T, that's exactly. So that's the reason we can make use of this formula. Or you can use this one, it's still the same thing, okay? That's 10 seconds. Oh, let's take a look at another one before we move forward. It said a body moving at 20 meters per second. The body is already moving with 20 meters per second. Decelerates uniformly at 5 meters per second squared till its speed becomes 10 meters per second. We have two speeds there. But they said a body moving at, that's that the body is already moving. That was the initial speed, the one it was given before, which is 20 meters per second. Okay. It decelerates uniformly with, here we're going to, the deceleration given is 5 meters per second, so I'll say minus 5 meters per second squared. And they said the speed becomes, that's the new speed is using now, which is going to be our final one, which is 10 meters per second. Okay, then we said the distance covered within this period is dash. Distance, that's S, that's what we're looking for. Okay, using this formula, don't forget, let me go back to that place so that you can see. We have UAVS. Sorry, you have UAVS. UAVS. So this is the most suitable formula we can use. So the formula there is what? V squared equals to U squared plus 2AS. All right, let's go back to that place. So we have V squared is equals to U squared plus 2AS. All right. So from here, our V is 10. So we have 10 squared equals to, what's our U? 20 squared. Don't forget that. Then this one will become minus, because we have deceleration here, minus 2 times 5 times x. Okay, this will give us 10 squared equals to, what's 20 squared? Oh, 20 squared minus 10s. All right, so this will give us 100 equals to 400 minus 10s. Okay, if I move this 400 to this side, I will have 100 minus 400 equals to minus 10s. That's minus 300 equals to minus 10s. Then I can simply divide this by minus 10. All right. So therefore, we have my S now to be 30 meters. All right, don't forget from the last class we had, the units has been given. So we have that to be 30 meters. Okay. Let's quickly look at another example here before we continue. Okay, we have a car has an initial velocity of 40 meters per initial one, that's U equals to 40 meters per second, and retards at 3 meters per second, that's retardation A, going to be minus 3 meters per second squared. Okay. He said calculate its velocity, that's final velocity, after 10 seconds, right? Good. So that's T now is equals to 10 seconds, that's the time. So we have UAVT. It's quite simple. If you go back to the equations, you're going to make use of the equation number 2. All right, so we're going to make use of this. So going back to that place, we have V equals to U plus AT. All right, so don't forget, so this will give us V, we are looking for that. U is 40, then plus, we have A to be minus 3, then our T is 10. So we have V equals to 40 minus 30. So therefore V equals to 10 meters per second. All right, the questions are quite simple. So I'm picking this question directly from Jambo past question. This one is this is 2017 question number 17. 2017 question 17. Why this one is 2016 question 48. Okay, we solved one earlier. This one I solved there is question number 50. Let me just write question 50 plus 2015. Okay, so we can have as many as possible questions. Just note you have different ways to solve them in accordance to the parameters given. All right. So there's a kind of important note we should have. Another thing is when we are dealing with velocity time graph. So when you have, I will explain this. The first thing is whenever you have velocity time graph, this is just saying change is like changing velocity over time, and that was what acceleration. So the velocity time graph, the slope of a velocity time graph will always give you acceleration. Please make sure you know that first. Okay. Now, yellows have 0 here, and which is also O. 0, which is also known as the origin. Okay. So please let's take note of that also. Okay. Whenever a body starts from rest, this one is showing that it's going, velocity is up here in meters per second, y time is in seconds there. All right, so if you have this, it starts from here. Okay, so that shows that, let's assume this place here is 15 meters per second. So when the body reaches this place, that shows that it has covered or is using the speed of 15 meters per second square, and there will be a particular time that is associated with this. Let's say this is 10 seconds. That shows that a body starts from rest and accelerates until its speed becomes 15 meters per second in 10 seconds. So here now, if you've been asked to interpret this graph, that is that where does it start from? 0. That's the initial speed is equals to 0. Then the final one, the one it's using now, is equals to 15 meters per second, and the time given now is 10 seconds. You can simply calculate your acceleration, which is v minus u over t from there. Okay, and you can even calculate your distance, which is s equals to v plus u over 2t. Don't forget this. So these are the things you really need to know first. Okay. So let's assume after getting here, the car now moves in with a uniform speed. All right, that is, uniform speed simply means no acceleration, no deceleration. So it's just a constant speed. The speed is, it was using here, it's still the same speed it's using here presently. So let me use that to make sure that's okay. The speed here is equal to the speed here. Therefore, there's whenever you have uniform speed, there's nothing like acceleration. There won't be anything like acceleration when a body is using is undergoing uniform speed. Please note this, it's quite important too. So now, so let's assume it's maintained this from here, it's now take it up to, let's say we have 40 seconds here until it was brought to rest. And let's say we have 55 seconds there. So how do we interpret this? This middle here, where it's used, it's just like if you are using A equals to V minus U over T. This is your V, which is 15 meters per second. and your u is also 15 meters per second. Okay, so by the time you put 15 minus 15, and that becomes 0, nothing for you to do. But you can calculate the distance. That's v plus u over 2t. Here our v will be 15 plus u is equals to 15 altogether over 2. Then the time, this minus this, because between 40 and 10, we're going to have 30 seconds. So that's times 10. You can simply solve this and work it out and get your stuff. While the last stage here, the car now is brought to rest. The speed here now equals the final one will become 0 when they ask you to calculate the deceleration. The final velocity equals 0, but the initial one, the one it was using before here, is what? 15 meters per second. So if you are calculating the retardation there, it's the same formula here, but this now becomes 0 because the v now is 0 minus what's our u here, the one it was using before, it becomes 0, that's 15. And then the time, since this one is 55 here, between 55 and 40, that's 15 seconds. That will give you minus 15 over 15, which is equals to minus 1 meter per second squared. Okay, so exactly this is how you interpret graph. At times the graph might not be from the origin and it might not return back to the origin. Okay, probably you have something like this. You have 0, you have 1, 2, 3. So let's assume the car starts from here and it stopped here, and the time is 5 seconds. Do you know that the initial, this is where it started from, the initial now will be 1 meter per second. This is going to be velocity, this is going to be time. While the final one, this of v, is equals to 3 meters per second. So it's not all the time that it will always be. Let's take note of this. And the time is what? 5 seconds. So this is very, very essential for you to know. And another thing is if the speed, if a vehicle is a vehicle using this, by now you should be able to. So if we have a velocity, let's assume this is 10 meters per second, and the time here is, let's say we have, this is 5 seconds, then here we have 15 seconds, and finally we have 20 seconds. Okay, this is 10 seconds, and this is 0. This is 10 seconds. We know how to calculate the acceleration now, the deceleration. But what if they ask us, and you should know how to calculate the speed. So if they ask you to calculate the total distance traveled by this vehicle, that shows that you're going to change the color here to green. You're going to calculate the speed, the distance traveled here apart, then the one it traveled here, then the one it traveled here. So we have 3 different ones. So for this one, here now your v equals to 10 meters per second. Your u is 0 and your time is equals to 5. You always use this formula all through. Okay. Why in this one? This your v will be 10. Your u also will be 10. And distance between this one and this one here is 10 seconds. So your t here also will be 10 seconds. Why the last phase? Here now, because the car has been brought to rest, your v equals 0, your u remains 10, and the time 20 now and 15, that's 5 seconds. Okay, so you should note this thing. But then after you've gotten the distance in every phase, the distance traveled in every phase, then you can now do the addition of everything. That will be the total distance travel. But there's a shortcut to do this. If we check this out, this is from this. So this is a trapezium. All right. So I'll just name this place A, and this place is B. Then the height will be here. So we know the formula is equals to calculate the area, that will be half A plus B times height. Okay, so I think this is the formula, right? So if this is the, therefore, we can simply change. If I want to calculate this distance traveled by this vehicle now, my A will be from here to this place. What is the time? From here to this place, that's 15 and 5. That will be 10 seconds, right? This is my, I'm using this now. Now my B here will be from this to this place. That's 20 straight away, 20. And my height now will be from down here to this up here. That's 10 minutes, that's 10 seconds. Sorry, 10 meters per second. So I can simply put it into this formula, which is half A plus B H, which is the same thing as half times open bracket, that will be 10 plus 20, then times the height is 10. So this will give us half times 30 times 10, which is something as 15 times 10, which is equal to 150 meters travel. So if you try to do it one after the other, you still get the same answer. So this is just like a short cut. Okay. So from here now, we are going to move on to equations about equations under motion. Equations under motion, then I will come here. Okay. We have motion under gravity and projectile motion. So when we're talking about motion under gravity, there are some things that will change. At first, now we are not dealing with ordinary motion, we're dealing with motion of objects moving upward or coming downward. So for this reason, our A, the acceleration now won't be A anymore, it becomes acceleration due to gravity, which is constant. It is, the value is 9.82 meters per second squared, but which can be approximately, 10 meters per second squared. Okay, let's note this first. And now we have two different scenarios here. When object is moving upward and when object is coming downward. Let's take note of this. When object is moving upward, we have the A now won't be A, it becomes negative of G. Okay, that's the first issue. No, that will be using negative G. Then our V, the final velocity of every object moving upward, is equal to 0. These two things is quite important. Okay, but when the object is coming down, A equals to positive G, and our initial velocity always equals 0. We don't need to tell you that it is a constant that we should know. That whenever object is moving upward, our acceleration to gravity will always be negative because it's working against the gravity. And when it's coming, when it's going upward, the final velocity always equals 0. But when it's coming downward, our A will change to the acceleration due to gravity, and the initial velocity is equals to 0. From here, you should get to know something. So, treating the equations, let me quickly write the equations there. We have V equals to U plus AT. We have V squared equals to U squared plus 2AS. We have S is equals to UT plus half AT squared. Okay, these are the equations we've got. Now, picking this first one, bringing it under this place, which is V equals to U plus AT. Now, let's make the changes here. I told you that our A becomes minus G and our V becomes 0. So therefore, this V has become 0 equals to, we have U. Instead of having A here, it becomes minus GT. All right? But because we have minus G negative. So from here, I can move U to this side. 0 minus U equals to minus gt. Therefore, this same thing as minus u is equals to minus gt. Minus cancel minus. We have u equals to gt. Then I want to make t the subject of formula. Okay. From here, I will have divide both sides by g. Therefore, I will say my t now equals to u over g. But this u here is u of an object moving uy, that's object moving on y-axis, that's upward. If you have a graph like this, this is always your y-axis, this is your x-axis. So when object is moving, we call this one u subscript y. So therefore, our uy, let's note that, is always equals to u sine theta. All right. So I will change this one to this same thing as u sine theta over g. So note, if angle is being given in a question that a body is projected upward with an initial speed or with a speed of, when we're talking about it, since it's moving upward, your final velocity is equal to 0. Any speed given to you, or any velocity given to you, will be what? Initial speed or initial velocity. So if it does have angles, then we use u sine theta over g, and if it doesn't, it's same thing as u over, just use a u over g directly. And this t here is known as time to reach maximum height. Okay, time to reach maximum height. This is small t is equals to u sine theta over g. All right, but if you are looking for okay, let me just try to draw this here. If you have a graph here, I think I have a video that really explains this better. So when an object moves in this manner, this is what projectile is like. So it moves in this manner, which is parabola. So the time it takes to reach this maximum height here from here, the time it took it to reach this place is known as time t. That's time to reach maximum height. But when you are dealing with the time it takes to move from here to this place and back to this place, that shows that you are dealing with the total time of flight, time it spends in here. So that's going to give you, this one is 1t, this one is under t. So that's it. The time, the total time of flight, that's big T, is known as small t, because that's this t plus this t, which is something as 2u sine theta over g. So please don't forget this. We are still dealing with objects moving upward, okay? We don't really have much problem with objects coming downward, but we'll still discuss that. Now, another thing we should know is that if you pick the second equation, which is b squared is equals to u squared plus 2as, since object is moving upward, this becomes 0 squared is equals to u squared, then this one becomes minus 2gs. So if I move this u squared to this side, then I will have it to be 0 minus u squared is equals to minus 2g squared. This is minus u squared equals to minus 2gs. So u squared is equals to 2gs, dividing both sides by 2g. Therefore, I'll say s is equals to u squared over 2g. This s simply means the maximum height, that's the total distance traveled. That's maximum height reached is equals to u squared over 2g. Don't forget what I said about the object moving upward is uy. So that will give us height now equals to u squared. Then when it's as angle, that's sine squared theta over 2g. Students, don't make mistakes. Yeah. Students do make mistakes. Instead of having, let's assume your angle here is 30 degrees. So this is the way you're going to calculate this. You look for sine 30 first. After you gotten this is equals to 0.5, you now squared your answer. That will give you 0.25. So this is how you look for sine squared theta, not square of this, then you look for sine. Not that important. So sine squared theta is, you look for sine theta, then you now square it. Okay, this is how you solve this. Let me quickly give you the range. The range, when we are talking about range, that should that we are talking about, sorry. Okay, the distance, the horizontal distance from here to this place, that's the range from here, from this side to this side, that's the horizontal range. And together, the formula is u squared sine 2 theta over g. Okay, we are not going to prove how we got in that. U squared sine 2 theta. Now, this one is different. If your theta is 30 degrees, then that will be sine 2 theta. That's 2 times 30. That will be sine 60. So that's sine 60. So we have this one to be u squared sine 60 over g. So please note this. This is difference between range and maximum height. So now let me quickly go back. We have t to be uy over g. That's u over g. It's also known as u sine theta over g. Then we have big T. This one is time to reach maximum height. Now total time of flight, which is equals to 2t is equals to 2u sine theta over g. All right, so here we have the maximum height reached to be u squared sine squared theta over 2g, and the range to be u squared sine 2 theta. Don't forget that over g. So note this is quite important. It is very, very important. Please note this. All right, so we'll continue from here in our next class. So try to make use of this to solve as many as possible questions. All right. So we've not finished this topic anyway. Okay, but the only thing that let's quickly finish it up so that you try as many as possible questions. If you have any difficulty, make sure you comment and send the question. Of course, we will try to look into it, we'll solve it and send the solution back to you. Okay. Now we are through with the objects moving upward. Now, when they're coming downward, we've made some assumptions that a equals to g and our initial velocity is equals to 0. So taking the first equation, which is this one becomes 0 plus gt. Therefore, we'll say v equals to gt. Then you can make whatever you're looking for to solve that formula from there. And if you take the second one, which is v squared equals to u squared plus 2as, it becomes v squared is equals to 0 squared plus 2g. Therefore, v squared is equals to 2g plus. So this is it. Here we are. Please don't forget this. And the last one, which is s, is equals to ut plus half at squared. This particular equation is formalized used to solve a special type of projectile. Now, I'm going to make a kind of diagram. Let's assume we have building that looks exactly like this. Okay, this is the building here. All right, when it rains, the rain always comes in this manner. Okay, good. It doesn't fall directly by the wall, but there will be a kind of space between it and this wall. So this one is known as S. I'll call it S. Why the height from here to here is known as height? Please note this. It only this is only applicable to when object is coming from up. So the distance between the foot of the wall and where it lands is known as S distance, while the height of this wall is known as H. So I'm going to split this equation here into two. I will say this UT, this first part, that's our S. That's to solve this one, UT. And this one is going to be our height. So our height is equal to R. Now don't forget this becomes GT squared. So this is going to be half GT squared. So whenever you have questions, always make use of this to solve the problems. And I strongly believe if you follow this vividly, you'll be able to solve any kind of question that comes your way, okay? And if you don't understand anything, as I said, please make sure you leave your comment below. All right, see you in our next class. Before then, I wish you best of luck.